All right, class, let's begin. I have to re-record this because I forgot to record it in class. So I'm going to re-record this piece of just one half of the class itself. So let's do that. And then the rest of the class is recorded. So let's do this here. On the YouTube channel, I'm going to have today's date on it. And it'll say this one, and the next one will say continuation of this. But anyways, we are in 1.2, almost finished up with 1.2. Technically, if you want to think about it, this is 1.2. This is part 3. It's been taking us a long time to get through this part here. So let's go for it here. We are dealing with circles, and we should go back real quick here in our notes here. So if we want to go back to over here, just the equation for a circle first. So x minus h to the second power, this little piece right here, y minus x to the second power is equal to r squared. What does that have to do with anything? Is the fact that h and k are your center. And the only thing we got to be mindful of is these little minus signs, because so technically it's the opposite of h and the opposite of k to get your center. And the r, notice, is r over here, but r squared over there. So it's going to be the square root, or you can write it as r squared. It's normally written as r squared inside the equation, just so us to know. All right, so let's jam. This is stuff we did last time. That's stuff we did last time. We finished actually here. So let's go do this one here. Find the center and radius of the circle, and then sketch the graph of the circle as well. So let's go for it here. So center is at opposite of this number here, which will make a 1. Opposite of this number here would make a -3. And then the radius is going to be whatever this number is, 9, and then you take a square root of that, so 3. Okay, so how would you graph this? Best way to do it, here it is. So we're going to go out 1 here, we're going to go down 3. We're going to place a little dot right there. So that takes care of the center right here. So how do we take care of the radius here? So what we do here from this dot, all we're going to do is we're going to go 1, 2, 3 up. Now I'm going to erase this here that's kind of what we're doing. So we're going to go 1, 2, 3 up. We're going to go, in fact, I should put tick marks here, 1, 2, 3. So I'm going to go 1, 2, 3 to the right. I'm going to go 1, 2, 3 down. Now I'm going to go 1, 2, 3 to the left. Okay, when I get that, so what I'm going to do is I'm going to just connect the circles with a curve, or sorry, connect my extra dots here with a curve. So that's probably the best way that I found, at least, to graph a circle freehand. So at least you know how far you're extending in 4 directions. So the circle doesn't look like it's all just kind of messed up. So there it is. There's your kind of close to a circle, but pretty good for us as we're drawing it rough hand. Okay. And of course, I'm going to torture you with fractions here just for a little bit. So can you guys do this one by yourself? Give you guys a 30-second head start. I'm going to pause the video. And we are back. So you should have something that looks like this. Center is going to be at 2, -3. There's your center. Radius is going to be this number here, which is 16/9. And as we take a square root of it, would be 4/3, or technically 1 1/3. So we're just going to go barely a little tiny bit out. So if we know we're going to just barely go 1 1/2 out, or 1 1/3 out, my hash marks, or my tick marks, I'm going to make them to be kind of very wide. 1, 2, 3, 4, 5. I'm going to make them very wide so I can see what I'm doing. And so this is at 2, 1, 2, 3, 4, 5, just so you can see it. So the center is at 2, -3. So there's my center right there. So, okay, now I'm going to have to go 1 1/3 away from there in 4 different directions here. So I'm going to go 1, and then a third more should place me about right here. 1 unit away, and then a third more should place me about right there. Going down, that should place me a little bit under -4. and 1, and then a little bit more should place me about right there. That little 1 is kind of a little bit off here. I'm going to just change it. That should have been about more like right here. Okay, and did what we did last time here? Let's do what we did last time here. So just take a time to make a curve, and you're going from one point to another, and you come back to it, and that is it. There's 1.2 done. All right, we are going to do some more though. So we have still the next section to do, which is 1.3. So let's change gears real quick here. That was the last 2 problems there. I'm going to end the show. Grab me 1.3 or a blank lecture to give me 1.3. And now we're going to start writing here. So finally, we have come to linear equations in 2 variables. Okay, so let's do this. Before we begin, I'm going to just jot down all the equations we're going to use. Okay, so one equation that we're going to use is something called the slope intercept form of linear equations. Slope intercept form looks like this. It's y is equal to mx plus b. And do you guys remember that from algebra 1? M is going to be our slope. B is equal to the y intercept. Okay, and then I'm going to put a little asterisk right over here, and I'm going to say this equation is used to graph. That's primarily the reason for it. Primarily the reason for this. Okay, next one is just the slope formula itself. Slope formula. Maybe I put like this little dash mark like this so I can separate those out. All right, you guys should also know this from algebra 1. It's y2 minus y1, x2 minus x1. And what we do is to find slope. That's what we do. All right, one more that we're going to use throughout this section is something called the point slope. Actually, I should say form over here because these are all linear equations. So that's why we say form, because it's a slope intercept form of a linear equation. This is just a slope formula. This is the point slope form of a linear equation. It goes like this: y minus y1, mx minus x1. Cool. Okay, then what do we do it for? To get equations from, we could say this, from graphs or descriptions. So we're going to describe it. So it says, hey, this graph has a slope of 2 and it goes to the point 1, 3. And then we sort of go through that way. Okay, so we're going to go through this rather quickly here. I know you know this from algebra 1. So we're just going to plow our way really quick here through 1.3. So first things first, example 1, we're just going to graph these. Graph all of these here. And if you can graph them before me, that's cool. I'll just kind of quickly go through it. So there it is. If you can go ahead of me, that's fine. Go for it. So if you want to label things here, you know your slope is 3/4. You know your y-intercept is -1. Based upon those 2 pieces of information, you should be able to graph your line. So we begin with a slope-intercept form. So let me change pins just so we see a little difference in contrast here. So -1 is where we begin. That is that point there. And then how we go from that dot is we're going to go up 3 because the top of our slope formula is the change in our y values. And we're going to go 4 to the right. So from this dot that we had already, we're going to go 1, 2, 3. 1, 2, 3, 4. And there's going to be my next dot. I should technically erase these because they're not any part of any equation whatsoever. Okay, first things first, let's connect them with a straight line. And then also I want you guys to put arrows at the end right here. Want to fill in the arrows? That's fine, but you have to have arrows because these guys are lines, not line segments. These guys keep on going. All right, then we go to the next one. Not sure why I have that 1.1 there all the time. So B, graph for me this one. Give you guys 30-second head start. All yours there. All right, let me come back to this here and then, oh, you know what? I'm gonna do it with red. Mm-hmm. Mm-hmm. We're going to start again at 4, 1, 2, 3, 4, my y-intercept. This time we're going to go down 2, and still, because 3 is positive, we're still going to go right 3. So down 2, 1, 2, 1, 2, 3, puts me right there. And got to move my computer over a little bit here to make sure it goes in like that nicely. Arrows at the end, don't forget. You don't have to color them in like I'm doing. And I have a question for you. Talk to me about this here. I have a negative 2/3. Is that the same thing as saying this? Ooh, okay. Let's talk about it here. So as a fraction, going back to 4th grade, guys, 4th grade math here. If I say negative 2/3, is that the same thing as saying negative 2/3? Hey, I say it the same way in English, negative 2/3, negative 2/3. Okay, so with fractions, the negative could go different spots. It actually can't even go down here. This is all true right here. All these 3 are the same exact value. So the negative could be on the bottom. The negative could be in front of the fraction. The negative could be on top of the fraction. All mean the same thing. But in terms of slope, let's see what it does in terms of slope. This means we go down 2, right 3. So hold on, if we go, let's go the other way here then. If we go up 2, since this is negative, up 2, we go left 3, would we still end up having the same exact line? Let's try it. Let's try it. So purple, I'm gonna do it by purple. So I'm gonna go up 2, 1, 2, and I'm gonna go 1, 2, 3. Check that out. I'm still in the same line. So if I were to form this line based upon these 2 purple dots, would I still have the same exact line? Absolutely. So yes, going down and right as opposed to going up and left is the same thing. Okay, we have 2 special lines that we talk about here. And one is like this, and the other is like this. All right, let's talk about it here. If you want to graph it, go for it and graph it here. I'm going to set up my graph paper here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to go here. Nope. Let me find it. Okay, there it is. Okay, so y equals 2. Where's the graph of this guy? And so what happens here, since there's no x and y relationship, It's just the fact that y is equal to 2. Let's check what that means. So that means y is 2 all the time. Y cannot change. It's a constant. It does not change at all. The x, though, could be anything you want because there's no constraints on the x whatsoever. So if it could be 1, could be 0, could be 3. I don't know. It doesn't matter. So if you were to plot these points, if you go 0 sideways and 2 up, that'll be graphing 0, 2. If you went 1, 2, so 1 to the right, 2 up, you get right here. Then 3 to the right and 2 up, you get right here. So notice, hey, look, what's forming? Yes, it is a horizontal line. Okay, so you don't need to do the table. You just need to recognize when you say, oh, you have y equals some kind of number, automatically you have yourself a horizontal line that goes through the y coordinate of 2. In fact, if you look at it, all these have a y coordinate of 2. Okay, the flip side, which I think you already know, x equals -3, that is going to be a vertical line, no problem. And then we have to find where's the x coordinate, a -3. So we'll go 1, 2, 3, it's gonna be right here. So in this case, it's going to be a vertical line, arrows at the end at -3. Okay, I'm gonna pause the video now, and the graphs might look a little bit different than I had them before, but the lecture is going to go on the next video.